Okay, so in today's Gressy Academy video, we are going to try and solve x to the power of 4 and 3 log x equals 4. And there are a couple of very clever little tricks to solve this, which hopefully you will enjoy. We're going to use the Lambert W function, so if you haven't watched our video, The Simple Guide to the Lambert W function graph, please go and watch that at your leisure on the Gressy Academy YouTube channel. For those who have, let's go straight ahead. And the first thing we are going to do is we are going to multiply the equation by that divided by that for a reason which will become evident in a couple of minutes time. So we're going to multiply everything by 4 over 3 log x equals 4 times 4 over 3. Okay, right, now what we're going to do now is we are just looking at here the log. We cancel the 3 out and we're going to move the 4 inside the log, which is going to give us 4 over 3 x to the power of 4 add log of x to the power of 4 equals 16 over 3. Now it's going to become a little bit evident why we multiplied in the first place by 4 over 3, because it means that we have x to the 4 here and x to the 4 here. And remember that what we're trying to do is we are trying to get the equation in the form z e to the z equals c, where z is a function of x and c is a constant, and then once we have it in that form we can use the Lambert W function to get our answer z equals wc. So that's where we're aiming for. Okay, so now the next clever little trick, what we are going to do is we are going to raise both sides of this to e. So we're going to have e to the power of, let's put it all in brackets, 4 over 3 x to the 4 add log of x to the 4 equals e to the power of 16 over 3. So we've raised everything on the left-hand side to the power of e, and we've raised everything on the right-hand side to the power of e. Okay, using the basic indice laws, a to the mn equals a to the m times a to the n. A to the m plus n. Sorry, let's just erase that. Using the indice law, a to the m plus n is a to the m times a to the n. Here we have e to the something plus something, so we can split it exactly like we had done here, and we can get e to the 4 over 3 x to the 4 times e to the log x to the 4 equals e to the 16 over 3. Okay, now remembering again, let's keep an eye on the what we're trying to aim for. We're trying to aim for z e to the z equals c. Now we're getting closer. Looking at this term here, e to the power of log x to the 4 is just x to the 4. So we get e to the 4 over 3 x to the 4 times x to the 4 equals e to the 16 over 3. Okay, we're getting very close now. If we look at the exponent, we have 4 over 3 x to the 4. And we're multiplying it by x to the 4. All we need to do now is multiply both sides by 4 over 3. And we get 4 over 3 x to the 4 times e to the 4 over 3 x to the 4 equals 4 over 3 e to the power of 16 over 3. And now we have our equation in the form that we wanted, where this is z, and this is z, and this here is c. So we have our z e to the z equals c. So the solution to that is z equals w of c, or using this actual equation, we have 4 over 3 x to the power of 4 equals the Lambert W function of the constant 4 over 3 e to the power of 16 over 3. And so therefore our answer, formally speaking, let's just go across here, is that x equals the 4th root. So what we're doing is taking the 4 over 3 over the other side and then taking the 4th root of 3 over 4 w of 4 over 3 e to the 16 over 3. And that is the solution to the equation x to the 4 and 3 log x equals 4. Now, it's always a good idea to actually check. So as this number here, 4 over 3 to the 16 over 3, is positive, I'll just draw very, very briefly the the Lambert W function graph again, although we should be pretty used to this by now. That's W0, and here is W minus 1. 4 over 3 e to the 16 over 3 is going to be, it's quite a large number, so it's going to be somewhere over here somewhere. So it's clear that there is only going to be one solution, so we only need to find W0. So let's just check what the actual value of x is. W0 of 4 over 3 e to the 16 over 3 using an online or scientific calculator gives us approximately 4.18863944. And then when we plug that into the fourth root of 3 over 4w of 4 over 3 e to the 16 over 3, we get x equals plus or minus 1.3313233. Now, looking at our equation that we were asked to solve, we have a log x in it, and log x, if we just draw a very quick log x is only defined for x greater than 0, so we can reject the minus solution. We can reject x equals minus 1.33 because log of minus 1.33 isn't defined for real numbers, and so therefore the answer, there is only one answer, which is x equals 1.3313233 approximately. And when we plug that value of x into this equation here,